Okay guys, so today we're going to be looking at integration techniques, integration by inspection. We have four rules that we're going to be looking at, starting with the power rule. So the rule says that the integral of f of x to the power n times f prime x dx is equals to into f of x all raised to the power n plus 1 over n plus 1 plus c. So in simple terms, this means that in order for you to be able to use this rule, this term here must be the derivative of whatever is in the brackets, right? Then the power rule also says that n can never be equals to a negative 1. Right, now let's go straight to the example. And then another important thing is that integration is very easy because it's like inverse operation of differentiation. So that means that if you understand your differentiation rules, you can also understand integration. Plus, again, for whenever you're working with integration, you need to have your formula sheets with you, just so you understand how to use it for the case of your tests and exams. Right, let's go to the first example. So the first thing is to analyze the equation, check if it satisfies the rule. If it doesn't, then you have to manipulate it in a way that it ends up satisfying the rule. Now let's look at the first example. It says that find the integral of 10x plus 1 all raised to the power of 4. So in this case, my n, when you're separating the terms, my n is equals to 4. And then my f of x is equals to 10x plus 1. Then we have to derive this. So deriving this, the derivative of 10x is 10, derivative of 1 is 0. Therefore, the derivative of this is 10. Then we have to rewrite this equation. So integral of 10x plus 1 all raised to the power 4 times the derivative, which is 10 dx, right? Then how do we then get back to the original? We have to multiply this whole thing by 1 over 10, just so it goes back to its original form. Right, now you check again if it satisfies the rule. If it does, then you can just apply the rule. So you're going to have 1 over 10 into 10x plus 1 all raised to the power 4 plus 1 all over 4 plus 1 plus c, right? Right, okay, in fact this bracket here is supposed to be here, so yeah. Then this is 1 over 10 into 10x plus 1 all raised to the power 5 over 5 plus c, close brackets. Then the final answer will be 1 over 50 into 10x plus 1 raised to the power 5 plus c is the answer. Right, so the key here is to actually analyze the equation, check if it is in the format of the rule. If yes, then you can apply the rule. If no, you have to then manipulate the equation to a way that will actually satisfy the rule. Now let's look at the second example. Find the integral of roots of cos x times sine x dx, right? So we know that if there is a root, that means that that particular function or term is raised to the power half. So this can be written as cos x raised to the power 1 over 2 times sine x dx. So again, in this case, my n is equals to 1 over 2, and then my f of x is equals to cos x. Now, what is the derivative of cos? We know that the derivative of cos is negative sine x. So here we must have a negative, and then in order to go back to the original, we multiply by a negative 1 here, right? So this is, then you check, then it satisfies the rule, you apply the rule. So it's minus into cos x to the power 1 over 2 plus 1 over 1 over 2 plus 1 plus c, close brackets. So it's minus into cos x to the power 3 over 2 all over 3 over 2 plus c. Now this can also be written as negative 2 over 3 into, in the root form, this will be square roots, then cos x to the power of 3 plus c, right, as the answer. I hope we are still together. Right. Now let's move on to, sorry about that, third example. Right. So what do we have on this one? Number 3, find the integral of e to the power 2x all over the square root of e to the power 2x plus 3 dx. Right. So obviously the rule is to simplify and integrate. Right. So let's simplify this. Integral of e to the power 2x all over. We know that anything with a root means that it is raised to the power of 1 over 2 dx. Then the numerator can be taken up to the, the denominator can be taken up to the numerator. Right. Then, so this can be written as e to the power 2x plus 3 to the power negative 1 over 2 times e to the power 2x dx. Right. And then the next thing is to actually check if the rule is satisfied. Right. Then let's see. Our n in this case is negative 1 over 2. And then my f of x would be e to the power 2x plus 3. Then the derivative of this will be, derivative of e to the power 2x will be 2e to the power 2x. Then derivative of a constant is 0. Therefore here what is missing is the 2. So you can just squeeze in the 2, and then to take it back to its original form we have to multiply by 1 over 2. Right, then the rule is satisfied. You can just apply it. So this is going to be 1 over 2 into e to the power 2x plus 3 all raised to the power minus 1 over 2 plus 1 all over minus 1 over 2 plus 1 plus c. Then this is 1 over 2 into e to the power 2x plus 3 to the power 1 over 2 over 1 over 2 plus c. Right, so simplifying this and this gives us 1. So the final answer will be the square root of e to the power 2x plus 3 plus c is the answer. Right, I hope this is clear and that you understand. Let's see if we have more examples. Let's see. Okay, for more examples you can always go, there's another page by my name, of which is yeah, it's still, we can just search for my name. There are more examples on power rule on that page. It's not an inactive page, but you can just go there for this particular problems on power rule. There are more examples there. Thank you. Bye. And please don't forget to subscribe. Sharp.